All right, let's just see what else should we look at here. Let's do an experiment. So we're going to take a little break. There's a ton of rules to go over, and I've gone over about half of the rules so far. I got a few more to go over. I want to take a break from rules and play a game. So let's take a look at the activity, and then we got to figure out how we're going to do the activity. So basic probability activity here. This one I made a discussion because I want each, and we're going to do it in groups, I want each group to see the results of the other groups. Pull that up a little bit. So we're going to explore probability through a game, and I wanted to do something a little different than flipping a coin or rolling dice, and so I thought a spinner would be fun, and this is one usually people can do at home. Now the problem with doing this at home is you have to have a nicely drawn spinner, and if it's too sloppy, then it could throw things off. So here's what I mean by that. So here's my spinner 1, 5, and 9 on there, and I'm just going to redraw that. So say I'm working from home here, and I'm going to do my spinner. And so on my piece of paper, and you guys know how good a drawer I am with this magic pen, sometimes good, sometimes bad. Ooh, that's a pretty good circle. And then I have to split it into 3 sections, and so I do this right here. Okay, so there's my 1, 5, and 9. Is that good enough to replicate this? If not, how are they different? I'm going to draw another example. Let's suppose Gary's brother, who's not as good a drawer as Gary, gets in here, and he does this, 1, 5, and 9 for his 3. What do you think about these spinners compared to the one I computer generated?
They're not going to work because you're going to be more likely to get a 9 in the one of them because it's bigger, and then the one on the other one is a lot smaller, so that they're just not equal probabilities.
Yeah, so this one for sure is a problem. If this is where my spinner starts and then flicks around, 9 is going to happen like half the time, and the 1 and the 5 are going to happen maybe a quarter of the time if those are right angles right there. With this one right here, this would be okay if this angle is the same as that angle is the same as that angle. And I did actually try to make those angles the same, even though I was a little sloppy about it. So I'm just going to grab a screenshot of my other one here. A nice clean one. So this one I had a computer draw it, and when I told the computer to draw it, add current please, I said, okay, there's 360 degrees when I spin around a circle, and so I said, okay, let's take 360 and divide it by 3, so that means each of these angles should be 120 degrees, 120 degrees, 120 degrees, because the degrees are what the spinny thing is covering, right? Every time it goes around, it covered 360 degrees. So as long as all of those angles are the same, 120 degrees each, then this is a good, fair spinner. So one problem with us doing this at home is if you don't have a printer to print this out on, then you may not have a fair spinner, and it could put you at an advantage or a disadvantage that we didn't mean to happen. Okay, so how do we cope with that? Well, we could pray everybody's a good drawer and can draw a 120-degree angle properly, and some days I'm good at that and some days I'm not. And I don't have a printer at home anymore, so if you ask me to print this, I'm like, oh, I could hold a piece of paper up to my screen and I could try and trace it, right? That's the best printer I could do at home right now. So some other ideas I came up with is I made a spreadsheet here, and spreadsheets have random number generators. And so I tried to use, let me blow this up a little bit. I tried to use the spreadsheet's random number generator to fairly choose a 1, a 5, or a 9, and you would hit F4 to spin. So every time I hit F4 on the keyboard, oh, come on, don't lie, it worked at home, F4. Ah, it doesn't work here. Maybe it's Shift F4. Control F4. Oh man, that deleted it. No, where'd it go? It worked on my home computer. Now I'm failing. F4? No. Huh. If somebody could do me a favor, bring up this spreadsheet, which is linked where? Over here. When I was at home, F4 made it work. Okay, so maybe on the other computers it's a different. Okay, so I tried Control F4. That was a problem. Oh, whoa, somebody else is making it work. Cool. Okay, is that me? No, I bet someone else is in there. Usually it shows me if other people are in here. Huh. Alt F4? Oh, Shift F4. Oh, what did I do? I'm just totally messing up my computer. Oh, not that one. Oh, that closed my whole browser window. All right, so I am totally failing at this today. I swear I tested this earlier. Well, apparently that's not going to work because the keystroke that I used earlier on my home computer does not work on my office computer, which means it might not work on your computer. Okay, so I got another idea in case that failed. Trying to come up with as many different ideas as we can to make this succeed. Another way I know I can make it work here. Oh, we have someone else there playing with it. Oh, somebody else is making it work. Are you hitting F4 there when you do that? Or is it just new people looking at this that's making a change?
I tried it and it didn't work. But
F4 didn't work for you. So one thing I know that will work is if I go into a different cell and I type anything and hit enter, it will regenerate the random numbers there. Every time I do it, it'll re-roll. Most spreadsheets have Excel. I thought had this. What if I download this to Excel? But not everyone's going to have Excel. So anyway, I'm trying to find a way to fairly spin for each of us so we can play this game together. So if I download this, reopen it in Excel, maybe the F4 works in Excel. Enable editing. Blow it up a little. All right, and I'll show you my other idea. I have two other ideas just in case. So here, if I hit F4, it doesn't work here either. Man, I thought that was it. F1, no. 2, really not that. 3, 4, 5, no. Shift F4, no. Control F4, no. Okay, well, I bungled that up. All right, let's go back and okay, so one idea that for sure does work here, yeah, you can go away, don't save, is every time we type something, it will shift it. So you could make your own copy of this by going make a copy or download it. And then you could pick your spinner, your neighbor's gonna pick their spinner, and every time you change what's in, say, this cell over here, that'll re-roll the dice. And how I made that happen, I'll talk about next class. You could look at the spreadsheet if you want to figure that out, but I'll talk about it next time. All right, so that's one option. Another option is to actually just roll a real dice. So let's go back to random dice. And maybe I use the random.org one, or maybe I use the Google one. I'm just going to roll one dice. And then since there's 6 numbers on the dice, what I could say is that if I get a 1 or a 2, that's my first number. If I get a 3 or a 4, that's my second number. If I get a 5 or a 6, that means pick my third number. So whichever spinner you have. So if I rolled a 2, I would get a 3. If I rolled a 3 or a 4, I would say it's a 4. If I rolled a 5 or a 6, it would be an 8. So that could work. Third option is this random number generator here. And what I told the random number generator here to do was to pick a number 1, 2, or 3. And then I said, give me 40 of them. And so this, for example, could be all the spins of the first column could be player 1, and the second column could be player 2. And this is your third number, second number, first number, second number, and so on. So if I had if I rolled a 2 here, that would mean back here, I got my second number, which would be a 6 if I was on B. So some way we have to find a way to do randomness for ourselves. And I'm going to split you into teams. And what I want you to do is I want you to each make your own table. Your table is going to show which trial you're on, what spinner you have. So you're going to say my spinner's B or my spinner's C, what your partner had, what you rolled, what you spun, what your partner spun, and whether you won or lost. So eventually you're going to make a table. And again, the table will have which trial you're on, and you're going to do this at least 20 times. So 1, 2, 3, 4, and so on. Whatever spinner you have, maybe I pick spinner B, and maybe my partner picks spinner A, and then my win or loss. So maybe I had spinner B and I got a 2, my partner got a 5 on theirs, so I have a loss. And then I just keep doing that over and over. This time I spun a 7, my partner got a 5 again, this time I won. And what we want to do is we want to use this data here to then answer some questions. And the questions we're going to answer are, we're going to make a guess first. Guess whether your spinner might win more often than your partner's spinner. But first we got to split into groups and pick spinners. And you can't have the same spinner. So you guys got to figure out how to equitably make that happen. And then for your spinner, like if I said I was picking spinner B, so 2, 6, and 7, based on my 20 spins, what's the probability of getting a 2? What's the probability of getting a 6? What's the probability of getting a 7? And then what's the probability I won against my partner? And I would just look at the 20 things and just count how many times I won. And that's what you'll submit. And I want this in everybody to see everybody else's results, because we're going to pool them all together when we're done, either today or next class, and look at the group data. And what we're doing here is we're comparing what's called theoretical probability to experimental probability. So a quick note on that, and then we'll do this. So theoretical probability . Theoretical probability means we know everything there is to know about the situation. And because we know everything, we can state probabilities exactly. Like, I believe I know everything there is about flipping a coin. It's either a head or a tail. Probability is 1/2 for a head, right? I think I know that exactly. Same thing with a dice, same thing with a deck of cards, same thing with a spinner. That's theoretical. Experimental is we run multiple trials of an experiment. And the experiment has to be repeated the same exact way each time. So like flicking a spinner, flipping a coin, rolling a die, me shooting free throws. And then we calculate probabilities by looking at the favorable outcomes divided by total outcomes. So favorable divided by total. And the difference is the probabilities in experimental come from only the observations we made. So like when I was throwing the free throw, I only threw it 3 times. So the probability of me getting it in was 1 out of 3 based on those experiments. If I did more experiments, it might change. And experimental and theoretical probabilities are related to each other, which is what we're trying to get an understanding of. So this experiment we're doing right here is about experimental probabilities, and then we're going to turn them into theoretical probabilities and do a comparison of them. And the more data we have, the better off we are.